Good afternoon, New Orleans. We are here. Talk about PowerShell. I got to tell you, I'm actually a little nervous today because I'm so excited about what we're going to present. I've been waiting to do this for way too long. So if I start, twitching my fingers or something, you'll know why. My name is Kenneth Hansen. I've been here a long time at Microsoft, been working on automation and PowerShell for the last almost decade. And with me today is distinguished engineer Jeffrey Snover.
Howdy. Howdy. So, indeed, I'm Jeffrey Snover, distinguished engineer and lead architect for Windows Server and for the System Center Data Center products. And indeed, I'm super excited about this talk as well. In 2001, I had this idea about how we ought to be doing automation differently than we were doing it. And I formed together a team of superstars. There was this guy down here in New Orleans presenting on a provisioning system. What did you call it? Microsoft Provisioning Framework.
That's right.
And I said, that's our destiny. I need that guy. And that was Kenneth Hansen. And we got together and formed a team of rock stars and started working on this thing that eventually became called PowerShell. And one of the first things I did was to write down our manifesto, right? Which is to say, where are we? What problem are we trying to solve? What are we going to do? How are we going to solve it? And what are the steps to solving it? And it turned out I wrote that in 2002. And if you read it today, it's actually a pretty stunning document because it pretty accurately reflects everything we've done. So in that, I said that there were 5 steps to a great automation system. The first was what I called the monad automation model. And this was an object-oriented model, a model of pipelines of objects instead of pipelines of texts, and all the benefits that would accrue from that. And then the need for an interactive shell to be able to do things, to be able to interact with things, to then lead to automation. And we delivered these things in PowerShell version 1. I also talked about the need for monad remote scripting, the ability to say, hey, I run scripts here, but I want to run it there, and across lots of machines. Okay? And we delivered that in PowerShell version 2. I also talked about this idea of the monad management console and the idea that all administrative GUIs need to be layered on top of the automation layer, so that anything you can do in the GUI, you can also do through automation. You can automate it. Do it on one machine, and then do it on all the rest. Okay? And you see with PowerShell version 3 and Server Manager, all of Server Manager, everything you do in Server Manager that we delivered in Windows Server 2012 can be done through PowerShell. And the last thing I mentioned was this idea of monad management models, that having built this base infrastructure, we then needed a layer of management models to solve specific scenarios. And that's what version 4 brings about. The first of these management models, and that is around desired state configuration. So finally, after 11 or 12 years, I finally got Kenneth to do what I asked him to do. Okay?
He's still working on that part of it.
So let's talk about this stuff. Anybody recognize this guy? This guy's awesome, right? Jean-Luc Picard. This guy was awesome. He'd take a look at the situation and he'd say, make it so. And that, just make it so. Here's what has to be done, just do it. And then there's this guy, right?
I just want you to guess which one of us is which.
Yeah, which one takes 14 years? Anyway, so this guy is the guy responsible for making it so, right? And he mumbles under his breath and then just says, yes, sir. And the details, good old Jean-Luc Picard's drinking his Earl Grey tea. I don't care about the details, man. You just make it so.
That's right. We're getting there.
And that's the point around desired state configuration. That's the world we want to get to. A world where you figure out what you want, you say make it so, and somebody's doing all the hard work and only bothering you or only talking to you if and when the objective cannot be achieved. Okay? So this is the basic model. Talk's over.
That's
right. Okay, well,
you got it.
Maybe we should show you a little bit.
All right, before we get to there, let's talk about the real world for a second, because the movies are great, and what's wonderful about a movie is they have this thing called a script, so it always works the way it's supposed to.
I like that.
In the real world, it turns out that there's a couple of things that are really driving us for the last few years towards difficulty in management. The first one is scale. We just have a ton more compute power in the world around us. How many of you have a mobile device with you? Thank you very much. I was feeling pretty safe there. Now, the second question says, of those applications on the mobile device, I bet 80% of them contact a server somewhere. And that server's got to get managed. So every time somebody buys one of those mobile devices, somebody else in a back room buys servers, tons of them. And the problem, that's wonderful, because somebody's making money. We like that. We like money.
Yep.
Okay, good. But it's horrible, because every time you buy another server, your odds of failing increase, right? The more servers you have, the more likely you are to screw something up. It's a lot easier to manage one than 1,000.
Right, lots of moving parts.
Unless you're doing it right. Where's the forward on this thing here? Ah, there we are. Now, here's the other problem, change. Market's changing more and more and more rapidly. Rates of adoption of those devices and software are on a steady ramp up, exponential ramp, compared to when you dealt with, VHS to CDs and whatnot back in the day that I remember. At least, it's been a much, much, much quicker. And that's vital. In order to maintain a technology, in order to maintain an edge, you need to be able to adapt and therefore adopt what your customers need. As we know, anybody who's done any management, the primary cause of failure is change. Can't live with it, you can't live without it. So what it really means is that life in the cloud, and I do put parentheses, I like life in the cloud, but from a management perspective, it really says that it's rapid change, at scale, ipso facto, constant failure. And this drives us to a different way of thinking and delivering capabilities.
In fact, the DevOps guys, are you going to talk about this?
Yes,
No.
Go ahead.
Oh, well, the DevOps guys have this model where they're continuously deploying, right? Continuously changing. DevOps started with a talk that said, at Flickr, we do deployments 10 times a day. So when everyone else was struggling to get a release every quarter or every 6 months, these guys get up there and they say, we redeploy 10 times a day. People are like, I don't think I understood that. And the answer is, yeah, that's the model we're moving to. So in that kind of rapid change, you need a new set of tools.
You do. So what he's talking about is this idea of continuous deployment up there, right? Continually deploying new changes. But what do you want? You want service availability at the same time. The only way to have your cake and eat it too here is with automation, but not just automation. It turns out there's good automation and there's better automation. And today we're here to talk a little more about better automation, because the goal is to drive from idea into development, from business idea into development, into operation just as smoothly as possible, like stuff flowing through ducts. It's like just as quickly, as simply, as fast, and as productively as possible. All right. Enough slides?
Yeah.
Can I start doing code? Okay,
Yeah.
Thank you very much. So, what is desired state configuration? We're here to talk about PowerShell and desired state configuration. So if this thing will switch over, there you are, code. Behold. This is PowerShell and desired state configuration. Now, before I go through it in too much detail, I am going to start it, but I want to show you what this is. What I'm now going to do is I'm going to take two web servers, web server 1 and 2. I've already got some VMs, and I'm going to ensure that IIS is present and that ASP.NET is present on those boxes. You got it? And so that's exactly how I do that. I simply say assert, I lied, website 1, and return. Now it's going to put out a whole bunch of stuff, and I'll come back and show you. Don't get too worried yet. Yeah, it takes a little while to install IIS.
Yeah, we're going to show you this stuff a number of times. So if you see it at first glance, you say, what am I looking at? And so we're going to walk through it a few times, and you got to get it in focus. It's crazy cool.
At least we think so. So what did we do here? Well, what we added is we added this keyword called configuration. We own a language. And many people, in fact, throughout time have tried to create declarative and imperative language. We'll get to that a little later. But we've added the notion of configuration, which is a declarative model to the imperative language of PowerShell. And this is very similar, in fact, to a PowerShell function. If you know the PowerShell function syntax, this is identical. This is a configuration function called Fourth Coffee website, right? Inside of a configuration function, we've added a new keyword, node. Node takes a list of targets. It can be any random arbitrary list of targets so long as they exist. If they don't exist, it just won't do anything with them.
It'll work, but
System will work, but they won't get installed. And then within each node, within all the nodes specified, we are going to say, hey, we want to invoke the Windows feature resource. And the Windows feature resource, we're telling you we want to ensure that IIS is present, or in this case, the web server. And we called it IIS. That's all we're saying here. And then here, we're just making a basic PowerShell function call. Fourth Coffee website, it generates an intermediate language, we'll get to that a little bit later, which then we can deploy using start DSC configuration. That's what I ran. I just ran that script. Let's go back and...
Oh, wait, can I say one thing?
Please.
So here, you said that it's really important to understand. This configuration really is a function, okay? So if you wanted to, it'd be very easy to go in here and add a param block, okay? And parameterize this thing as well. It is literally a function. Okay, and you'll see more about that, but I just want to get that in focus.
Please.
So you're declaring something, and it has a name, and then when you give that name, down here on line 23, it runs the function. In this case, it runs the configuration, which is to say, to create the configurations.
Go for it. So, where the hell, there's my mouse. There it is. So actually, it ran all the way through. We'll check it just a second.
And what we did was we ran it with verbose. The yellow is all verbose stream.
And this is kind of interesting because we specifically start talking about what are we doing. This is a local configuration manager.
LCM, local configuration manager.
And here we're starting a set, we start test, and what you'll see here is a series of tests and sets. And what that means is for each one of those configurations, we're testing, hey, was that web server IIS present or not, right? If it's not present, then we're going to go ahead and call the set to make it so. Here's start of a set of Windows feature IIS. Do you see that? Windows feature IIS now going to start on what server do you think it is? There it is, on web server 1. Make some sense? You can just scroll down exactly what was happening on the system. We think that's really important. These systems do a lot under the cover, so it's important to sort of expose as much as we can at the higher level. So let's make sure, in fact, that it is verily so. In theory, IIS's default website should come up. And there we are. OK, we did install. I'm not lying.
So just to make sure you got that in focus. So we used extensions to the PowerShell language to say, I want to have two servers, Web Server 1 and Web Server 2, and here's the things I want installed on them, ASP.NET and IIS. And I said, make it so. And then we did make it so. It's called Start DSC Configuration. And you give it that, and we go and we make sure that the agent goes and texts to make sure that that world's that way. It discovered that it wasn't, and so then it made it that way. It did that number one task, make it so. It went and said, oh, IIS isn't there. I'm going to install it for you.
All right, now we're going to up the game just a little bit, because IIS is kind of exciting, but we'd rather see something else. So here,
it's parameterized.
It's parameterized, exactly. And so here we've actually done a little more. First, let's talk about the parameters for a second. What's this thing? This is node name, right? Remember I said we've blended the notion of imperative and declarative. Anybody remember Prolog? I did that once, right? It was a declarative language. One, that's right. One admits to it. The rest of them. And declarative languages are very, very powerful because they let you simplify like we have here. Okay? But they also have a weakness that sometimes you need to get out and do something, or you need to actually grab the value, right, that you want to assign to the property. And that's a more imperative thing. You want to go to a website, download a CSV, do something complex. And that's the beauty of integrating PowerShell here, because now I have this imperative language that I can do anything I want to. This could be any PowerShell expression. In this case, we've chosen to make it node name, which is, as Jeffrey said, a parameter. Thank you very much. Exactly. And notice, by the way, the same basic PowerShell syntax. Everybody's familiar with PowerShell, I hope? If so, thank you. I'm getting nods at least. Otherwise, I'm in a lot of trouble today. This is a mandatory parameter, so it's required. If we were to try to run this function configuration and no one had specified that, then in fact we would fail. And now we can actually go through. All these things are just parameters. There's something else here that's really sort of cool, and that's the requires. What is this saying? This says that before I can run this resource, where this resource can check its existence, the system is going to make sure that this resource exists. Right? So we could have actually put these in any order at all. The requires allows us to execute them, to execute the dependency graph in the right order. We basically construct a graph, little pointers, and we say, hey, is what I require fulfilled already? The answer is yes. It runs the test. If the test fails, it runs the set. If the test succeeds, it moves on, and then the next guy says, hey, what I require, is that working, right? So also we have here, by the way, as soon as you notice this, we have kind of implicit parallelism going on, right? IIS and these depend on different things. They could go at the same time. These could go at the same time. So you don't have to specify it. It just sort of happens. Let's go ahead and run this while we're at it and see what we get out of here.
Do a clear screen. Yeah, so this is one of the key advances is this mixture of what's called imperative and declarative code. So declarative, things like XML, just here's statements, and then imperative, do this, check, look up that, etc. The mixture of these two is really important. It's how, in the world of materials, some of your strongest and most useful materials are in fact combinations of materials. Okay?
And so what we've seen here is it's starting to run, and this little skip set, you see that skip set? That was what I was talking about before. It said, hey, web server 1 already has the ASP.NET 4.5 already installed. So we're just going to skip the set and keep going. That's vital because we're going to want to run this again and again and again and again in what we call, because it is idempotent, right? That is a politically correct term. It just means that I can run things repeatedly and I get the same result. And so in theory, assuming our demos worked, we will get something besides the IIS up here. Drum roll, please. Thank you very much. Thank you very much. And we have cupcakes.
Cupcakes. Everybody loves cupcakes.
Yes. Ever since I've been running this demo, I have fallen in love with cupcakes.
It's a crowd pleaser.
Don't order them, though, because they're like just there to tempt you. If you click order, it won't work. Did I mention it was a demo?
Yeah.
Yes, okay, good.
And again, the reason why you see cupcakes here is because we said, as in part of our Make It So, in addition to I want IIS, I also want a website. And here is what I want my website to have. And we pointed to the website content.
One more observation, and then we're going to move on. And that's this notion of website. We've only going to provide, right now we're going to create a whole ecosystem. We've only providing so many out-of-the-box capabilities, but you are allowed to create your own resources. And this website is one we actually created ourselves just in order to manage the website. So we'll come back to that a little later. I want to make sure you got a heads up there. Shall I go?
Yeah. Great. So now this PowerShell desired state configuration, what is this all about? Well, it allows you to ensure that the components of your data center are all configured correctly. Okay? You're going to have these declarations, you're going to apply it to a set of machines, and then you're going to be assured that those machines are in that configuration. It allows this motion of continuous deployment and prevents configuration drift. Like, hey, did that thing, I set it, I got so many moving parts and so many people doing stuff, is it in the right state? And this model, because of what's called idempotency, or idempotency if you pronounce it incorrectly, allows you to just say, geez, I'm not sure. Make it so, make it so, make it so. And it will continue to resolve itself and make it so. So it's this wonderful world. In fact, we were doing our demos here, and as we do things, you'd set up demos, this breaks, that breaks, as you're getting everything. And it was just so wonderful to just say, clean the machine, assert the state, assert the demo, and it goes and configures it, and then you do it again. It's one of those things, we knew it. I mean, we developed it. We've been working on this for so long, and yet when we used it,
you start using it, go, wow, it worked.
It's just so
How did that happen?
It's just so awesome. Anyway, so it's quite wonderful. Now, concretely, it's a set of language extensions. Now, if you've been using PowerShell, you know that, hey, I could have done this before. PowerShell allows people, we intentionally designed it so that you could do domain-specific languages, and there are a number of them out there. Pisaki and Show UI, there's a number of them. But it turned out that there were some elements of the syntax that made it fragile. And what we did was we fixed those, and so it makes it robust, so it's easier now to develop domain-specific languages in PowerShell. We have this engine that then makes it so, okay? Now, someone asked me the other day, hey, this desired state configuration, is that a Windows thing, or is that a PowerShell thing? And there's a precise answer, and it's a really interesting answer, and you ought to pay attention. It is, desired state configuration is a standards-based management thing first implemented on Windows using a PowerShell language and WMI and a PowerShell extension model. Okay? Now it's going to take you a while to understand what that really meant. So let's continue on and we'll revisit it. But it's a really important statement. It tells you about what things you can expect in the future.
In the future.
Although I can't talk about them, so that's why I'm giving you like a big monster hint here.
That's right. The data center. All right. We're back on demo for a second. We are. Okay, so what I've done here is I've just gone ahead and entered a session on Web Server 1. That's one of these. That's this baby right here. And why do I want to? Because we're going to screw it up. Yes, right in front of you, I'm going to screw up my website. I am talented at this. I will have you know. I did this once completely by accident when I deleted not everything out of the root, but enough.
Fourth copy.
Fourth copy, yes. He's here to make sure that I really don't screw up everything. And we're just going to delete it. We're going to delete all the images, recursive. We're feeling lucky. We'll just say force.
Go for it.
He nods his head. It's his fault now, just thought I'd tell you. Now, it's the captain's decision.
By the way, this actually happened to me once when I was working at Apollo. Apollo was this wonderful uniform file system, but they had this one problem. When you were admin for the world. And I thought I was in my local working, this is a true story, I thought I was in my local working directory, and so I deleted everything, and it turned out I was in the operating system sources, and I went and got lunch, came back. Boy, it's taken a long time, and I deleted all the operating system sources. It was a really, really bad day.
That's right. All right, so here we've gone ahead and removed all the images for one website. We're just going to go ahead and stop website, fourth, coffee, watch my typing. I'm a bad typist. That's why I like up arrow. Okay, in theory it stopped, and if we come back here, prepare for a moment of sadness. Oh. And that's just going to take forever. All right, so that's somebody's...
So wait, go back to the one. Show them.
Sure.
You don't let it hit sync. So what happened is we lost our pictures because he deleted the images. Somebody messed it up. The website's up and running, but I've lost some stuff. The other website, notice that little spinny donut, it ain't coming back because he stopped it. So one of your interns has screwed it up.
Never happened.
Now, you can fire the guy, but if you fire him, you're just going to hire somebody else, and he's going to do the same
Screw
thing
it up
next
too.
week.
It's true.
So instead, you want to set it tools.
Thank you. I like that idea.
Because we're all flawed humans. There you go. That's the point. That was my point.
Thank you.
Look, I'm doing pretty well, my career. But at some point in my career, I deleted all the operating system sources for the company. People screw up, okay? And so what you want to do is you want to have systems where it's like, okay, not a problem. Not a problem. We'll fix it.
We'll fix it.
Yeah.
So in theory, we are now going to fix it. We took exactly the same thing we ran before. I just up arrowed and entered website 2. And if we are correct in our assumption, well, see, that's pretty quick. Now, why is that so quick, right? Because it's just checking everything that has already been set. It's not resetting. So it doesn't have to rerun it.
Most of the things it didn't have to rerun.
Oh, yeah. There we are. Hey. Think we can get over that? And we got the process. Thank you for the enthusiasm.
Sadly, this does not work for your operating system source code.
That's right. And you notice right here it starts to tell you, right? Because it has where do I got this test? It starts the set here on file content, right? That's the one it said. It said, okay, Web Server 1, your file content's wrong. I'm going to go ahead and reset it. and then at the end it finished that particular web copy in like point whatever it is seconds.
Hey, by the way, it's worth noting here. Take a look at what you're seeing. We know, right, in this desired state configuration, there's lots of moving parts. I say, here's the way I want it to be, and sometimes it does some stuff, sometimes it doesn't, based upon what it finds. And so we knew that your ability to have clear visibility into the inner workings was critical. So we spent a lot of time on this verbose stream. And so you'll notice here, as you use it, it's very easy to see. Notice it's very easy to visually parse. Somebody said, oh, you got to make it readable. I said, that's exactly incorrect. I do not want it to be readable. I want it to be recognizable. Readable, you got to read the stuff. I don't want to read it. I want to be able to recognize it, right? And so you just look at this stuff, and I can easily see a skip test. I mean, because I know where to look. I know, and you recognize it. So
it's true. Actually, he repeated to me the other day when I was making a change. He said, I want to be able to recognize, not read. He was right. We changed something, Captain. All right. With that, we can go back to slides. Oh, we got. Okay. Speaking of the captain. So here's actually what we've been trying to say. We're going to take it to the next step. What we've showed you so far is the separation. Where's your T? We need the T. Is the separation between the intent, if you will, the captain, and number one, whose job it is to go make it so. We separate those out. And that creates a great simplification, right? It was a lot simpler to just say, okay, I want IIS installed. That allows us to deal with the scale and the change much more completely. It turns out that once you start looking a little more, there's one more level of separation you really want. It's a little less obvious. And that's even on the, what I call the configuration side or the intent side, there's a difference between structural intent, structural configuration, and environmental. What do I mean? What I mean is, I'll come back and just so we can code for a second. What I mean is that, no matter where I am, no matter how many systems I have, the fact is I want IIS installed on them, right? I want IIS present. That doesn't change. That's structural. Now, the names of the servers might well be environment dependent. If I'm in my production environment, if I'm in my development box, it's just my development box. Maybe a couple of VMs I got local, right? Playing around. At some point, we're going to run it up to a test environment, and what's going to change? What's going to change is not whether IIS is installed or not. What's going to change is perhaps the servers involved, or perhaps where I get the files from, or anything else we try to parameterize. And so because it turns out that there's this important and consistent separation between structural configuration and environmental configuration, we've kind of hot-rodded the opportunity to do environmental configuration. You can do what we did here with parameters, or you can do something a little easier and make sure that the person who deals with configuration as they go from production and from test into pre-production into production only has to deal with one file and never touches your structural configuration.
Yeah, can I highlight that? So again, the DevOps community, a bunch of really creative guys doing a bunch of creative thinking, and they got very clear on this notion of these different environments, right, in the continuous deployment environment. A developer develops his code and he tests his code against a certain set of machines. He then hands it off to, when he's happy with it, he hands it off to the testers. As much as possible, you want to make no changes, but of course you have to make some changes because you're going to deploy it and run it against a different set of machines for test. So you only want to change those things required to specify the new machines, okay? And how many new machines. And then when you go into production, exactly the same thing. You want to change as little as possible. And so what we've done is we've taken that pattern and we have codified it in the conventions.
And in fact, what that looks like then is right here, we have this ability to go through and just state, this is all the environmental configuration. Now it's a choice, right? Depending upon your environment, some things are structural, some things are environmental. We don't make that call, we just give the opportunity. And here on the Assert website, notice it's very similar to what we did before, except we have this thing called $node. We've hot-rodded. And what that said was, hey, if I'm this node, I know my name. If I'm the second node, I know my name, right? So we know when you read in that configuration environment which one I'm operating on, and you have per node information stored and accessible.
Let's highlight, let's make sure. So this is a PSD file, a PowerShell data file, and this is a hash table, okay? So it's a hash table that has an element called all nodes, and then the all nodes, you basically have two sorts of things. One is something that's going to apply to all the nodes, node name star, that says for every node, here are the attributes I want to apply, and then everything else is a node. Here's a node, its name is this, here's a node, its name is that. That structure is the convention, you follow that convention, and then this, then you're going to see you pass that in as a parameter, and we use this over and over and over again. Are you going to talk about the new syntax?
Which one?
Ooh, check this one out.
Oh, yes, but not yet.
Oh, not yet. Pay no attention. Look, a deer.
Yes, because there's, all right, so, and just to prove that we haven't done anything too squirrely here, we're going to just run that same one. This is just the assert website dash configuration. In this case, I actually go ahead and take a configuration file because I have 2 or 3 different configuration files depending upon where I'm going. Does that make some sense to you?
So this would be like dev configuration, test configuration, production configuration.
And the goal here is this just doesn't do anything different. And then I'm going to show you one thing, and we'll talk a little more through it. OK, so that should, in fact, just make sure, this is just proving I've done exactly the same thing, and everything is all happy. Verily, it didn't screw it up. Let me talk to you just a little more. Well, let me actually start something off. There's a little more complicated version of this that we actually want to run through, just to show you how that looks. So this is similar, except what we've done here is I said, hey, I want, it's exactly the same file, a little more complicated, same all nodes that Jeffrey was talking about, same node star here. I've gotten a little more real about this. You'll notice I now have a system drive, right? I can take this thing, I can shove it to a different laptop. We have a few laptops right now currently running the same demo, and it just works. You want to change that to a 3? I do like more, but it takes a while to create a VM and install IS and everything else. And so with that change, that's the only change you're going to see me make to that file. And if the gods are with us, you will get we will have expanded our cupcake universe to 3 machines.
The cupcake dynasty advances relentlessly.
But let's talk a little bit about what we've done here. We've said, OK, we want 3 of these, and let's open up one more file and drill into what Jeffrey was alluding to here. All right. Right here. That's the special syntax. You want to take that away?
Yeah, so we again we changed we extended the syntax to make these declarative languages even easier, and so let me just I'll do something else. My favorite, right? $G.
You're not on the host anymore, by the way.
Oh well, that's not going to be good. How about
exit,
here?
though. Just exit.
Oh, okay, exit. I can say $G equals GPS. Right, $G, yeah. $G dot where name like star SS. Oh,
nope.
like, oh, which one?
No, not yet.
No, which one? Not yet.
This is the working code part of it that we're showing.
By the time it ships, I'll bet you Ken's job that this works.
Where? We've been changing builds like nobody's builds. It's been a lot of fun. No.
No?
No.
Well, that's just awesome. By the time
Sorry
it ships.
about that. I didn't know we were. But that's actually exactly the right terms of where we're headed, because we want to be able to do this where as a common syntax. It says, hey, where the role is equal to web, grab that node name, right? It's exactly it's the same notion that Jeff was demonstrating. It's just right now it's within the configuration statement as opposed to outside the configuration statement. So anywhere that is, you go for it. And then it just selects, by the way, as I say, that node, right? This, by the way, this little thing, role equals, up here, right? Role equals web. if I had another role, it could be I don't care what that property or name is. It could be any of them, which is what was cool about what Jeff was showing is, this is whatever you want. This is any expression against that set of hash tables. All right.
So the whole point of that is you're going to declare a set of nodes whose role is going to be SQL, roles are going to be mid-tier, roles are going to be web tier, and how do you want them configured? And then you're going to want to say, hey, I want to have these things configured, then those things, to have a unified configuration.
So you don't have to do that again and again. All right, so here what you've got is you've begun to actually do...
Oh, by the way, sorry, I messed
please.
that up. And the point of that is that when I'm configuring my frontier to talk to the SQL engine, I need to know, I want to tell the web tier the address or the connection string for the SQL engine. So you configure those things together. You say, hey, all nodes.where/SQL-engine.IP address, plunk it, get that value, and plunk it into my IIS configuration. That's the key point. That's where this declarative, I got to tell you, whenever you see somebody say, oh, I got a purely declarative system, just watch your wallet, right? Those things don't work very well. And they sound good, and they've crafted some example where I'm sure it all works fine, but in the real world, those things don't work very well. You need some declarative. In fact, there's a funny story about that. I don't know if we didn't plan this, but Bill used to beat me up. Bill Gates used to beat me up, and because these research guys had come up with this purely 100% declarative programming model. It's like, really? And because I owned all the management GUIs, it's just, you can rewrite all the management GUIs purely in XML. And I'm like, whoa, how is that possible? And it's like, well, they can do it. And I'm thinking, that's not possible. And he just beat me like you cannot. Bill would beat people. You cannot believe how badly he beat me.
He's good at that.
So finally, I go in and it's like, okay, well, show me this thing. You researchers, your big brain, show me this thing. And I looked at their XML, and they had things like for each. I'm not making this up.
Statement, right?
XML nodes,
right.
for each, and if.
Yeah.
It's like, that's your declarations. Okay, that's beautiful.
That's right.
Sorry.
It's true. It's exactly what happens. People start down the declarative model. They get so far, and then they said, oh, we need to add some imperative.
Oops.
To this. In this case, we've actually flipped the opposite. We've got imperative and then added declarative.
Yeah.
Either way you get there. So here in theory it's completed. Well, let's see what we've gotten. So, does this all work? I'll add a new tab. All right, web server 2, that's cheating. That's just because I'm lazy. I don't want to type it.
Oh, right. You added the third web server.
Third.
And?
It's spinning. There we are, cupcakes. All right, we have 3 cupcakes automatically. Got the web server added and running. And again, it's done all this reasonably smart stuff of doing the start, the end, the skip.
We'll tell them. There's a demo we didn't get working. We were going to go say, now make it like 300 and run it up in Azure, but we didn't have it working. But you'll be able to do that.
I bet his job on that one.
Cupcakes everywhere.
Everywhere in the universe. It's true. It would have been fun. All right, so that's the basic notion, though, I wanted to hit, which is this notion of, that's where you get the continuous deployment from, right? You change as little as possible, and you only let them touch the things that they really need to touch as you move. You don't want to touch your structural configuration. You sure don't want to touch that idempotent automation on the bottom end of it.
Yep.
You just want them to say, we're going to tweak just the littlest bit, and that's where you get less change, therefore less failure, much simpler system, therefore less failure.
All right, so let's talk about how this really works. So these are the innards. Okay, we're going to start from stage right. Okay, so there's 3 parts to it. Remember my statement. My statement was, this is a standards-based management thing, first implemented on Windows using a PowerShell language and a PowerShell extension model. Okay, so on the right here we have this make it so phase, right? That means that every single Windows server is going to have this engine, right? It's actually everything that has PowerShell on it is going to have this engine, PowerShell and WMI, excuse me. And it really is, it's a WMI provider. It's a WMI provider. We call it the Local Configuration Manager. It has a local configuration store that says, hey, what is the desired state? What is it now? What's the one that's supposed to be the case? And what was the previous one? Okay? And so when you say make it so, it goes into pending. This agent then goes and parses that, make sure that it's okay, dispatches it to the various providers. These providers can be WMI providers or PowerShell providers. As an extension mechanism in this first version, we're only supporting the PowerShell extensions, but you can see you can use any standards-based mechanism to extend it. And then they go and make it so, and when it all works, and these are what we call the imperative providers, right? So there you got code, imperative code.
That's number one stuff.
Yes, and then when it's done, it takes the pending and says it's the current. Okay, so it's that simple. Now, what does it work on? And it works on a fully articulated specification of the way the world ought to be. That is expressed in a MOF. A MOF is a standards-based management document, a DMTF standard of managed instances. You take that MOF document and you hand it to the local configuration manager, and then it makes it so. So then the question is, okay, well, where did you get that MOF? And here's the interesting answer. Any way you wanted to. Get it anywhere, any way you want to, right? So indeed, you can use Notepad to just bring up Notepad, create one of these MOFs, you're done. You got them off, hand it to the agent, it will make it so. You can use PowerShell version 1, 2, or 3. PowerShell is great for creating documents. You can use it to say, hey, open up a file, put these things in it, hand it to it, and then I'm done. PowerShell version 4, however, makes it easy. That's it. That's all PowerShell version 4 does, is it makes it easy. Okay, so we've added things like the declarative syntax extensions. We have schema-based IntelliSense. You haven't shown that, but we should show that at some point. So as you're creating these documents, we know what things you're configuring, and so we'll come up and give you IntelliSense. And then when you go to create the MOF file, we understand the schema, so we'll do schema validation to say, that property does not exist on that object, so you did something wrong. And so you know up front when you have a problem. So that's all that PowerShell version 4 does, is it makes it easier to create these documents. But you can create those documents any way you want. And in particular, third-party tools and other layered tools. You can have entire tool chains on top of these. And with that, I'm going to bring up Eric Winter. And Eric is from the SCVMM team, and he's going to show you how SCVMM is able to use this back end of the tool chain to do desired state configuration using the, what are we calling it? The CloudOS?
CloudOS Virtual Machine Role.
You should turn your mic on. The CloudOS Virtual Machine Role.
One more try.
Here. I'm on here.
Can you turn him on?
Now?
Now,
There you go. You're on.
Eric.
Yeah, so I think that's me.
And 7.
Oh, 7. There you go.
Yeah, so this should look familiar to those of you who saw the keynote or Jeffrey's earlier session in the day. And this is all about the new CloudOS Virtual Machine role. That's a new artifact and set of APIs that we're delivering first on-premise for creating scale-out multi-VM tiers of compute. So I'm going to show you how you can take the multi-VM tier and integrate PowerShell DSC. So here in our gallery, we have an item that we've prepared to make it simpler. You could just drop all your whole script block in there. Everything Kenneth's been doing, you could just drop right in there. But here we've made some friendly parameters. So I'm going to choose this. I'm going to give it a name. And these are versioned as well, so there's the ability to version these models and help enable app lifecycle across any of the CloudOS for Microsoft. I'm going to go ahead and next. Here I'm going to configure the virtual machine container. So I'm going to specify my domain name. I'm going to get my creds here right. And even the computer name here, we can hash it. Now here's a case where a lot of what Ken's been showing is, if you know your computers, you can go ahead and configure the environment and push to it. But we haven't created the computers yet. And they're going to be created with a pattern. As we scale in and scale out, the computer instances will come and go. So here I'm just going to do a base name here. And on the next page, I'm going to push the very same configuration files you saw Kenneth working, I'm going to stick those in this gallery item so that as we create the first VM in the tier, and as you scale it out, we'll push the exact same configuration file to every machine in the tier. This one is the website.ps1. The configuration environment, which in this case I'm using it to control the website configuration and some of the default node characteristics. But again, we don't know how many computers are even going to be here yet, and it's going to change as load changes. And this one is these websites are sort of placeholders today for somewhere where you might integrate DSC or your website with a source control system. TFS Online, you're going to want to pull your configuration and version it and do these releases, whether it's 8 times a day or not. So here I've got my bits cached just on a web server for convenience. Oh, you love that, don't you? That's going to reset our demo a little bit.
Just proving it's real.
All right, and that was really the end of the wizard. Let me just jump to this instance to save all my typing again. So I've configured the role, and I've started my deployment. I've given all the PowerShell settings to it, and you can see this one I deployed earlier on the configure page. There's all my virtual machine container references, and if I scroll down, here's all my PowerShell DSC artifacts that I've told the cloud provider where to pull these artifacts from into my VMs as they're instantiated. So what you can do then is go here to the Scale tab. I created one. I just want to have 3 more websites. I just click that one. Yes, I do want to scale out. So now what it's doing is creating the VMs. As soon as the VMs boot up on my domain, they'll take these artifacts, pull them down, and apply the PowerShell configuration to every VM as it's scaled out in the cloud.
Hey,
Yeah.
thanks, Eric.
All right.
Thank you.
All right, so you think that's cool. So I mentioned to you, this is about a platform play. And so we showed how what he showed you was a new tool, SCVM, and the Tal portal, or the Windows Azure portal, generating and using the back end to configure things. But it's an entire ecosystem play. So what I'm going to bring up here is Julian Dunn. Julian is from Opscode. Opscode has this very popular product called Chef, which does configuration management system, and it's quite popular in the Linux environment. And now we're going to show it working with Windows.
Good afternoon.
1, 3.
Make sure that's I'm still logged in here. Looks like I have a demo to go to. Great. So my name is Julian Dunn. As Jeffrey and Kenneth mentioned, I'm from Opscode. We're also, I feel like we're kind of long-lost brothers, actually. You know, like a lot of the stuff you guys are talking about, we're also doing as well. And we're based out of Seattle. It seems like, we're kind of like this mind meld up here on stage. It's actually quite interesting. And you guys are showing cupcakes, and our product is called Chef. So it really is.
There you are.
It all works together, right? Isn't that
It was
great?
planned.
Yeah.
It's all good.
Exactly. So Chef is a highly scalable automation system, as Jeffrey mentioned, and it's also declarative resources based. So it's just like DSC, right? We call it just do it, just like Captain Picard there, right? And just to continue with the cooking methodology or the cooking analogy, we have these things called recipes, and the recipes are written in a Ruby-based domain-specific language. And the advantage of Chef and the advantage of using it on both Windows and Linux is that it's really a heterogeneous ecosystem, right? A lot of folks, as they pointed out, right, a lot of folks are already automating Linux and Unix systems using Chef. And what we've done here for this demo is we've integrated the DSC work that these folks have done with the Chef code. So your system administrators could use the same familiar DSL across both platforms. Right, so Chef is actually used by a lot of shops, from the smallest startup right up to the biggest companies like Limelight Networks. Facebook uses us, and there's also a really huge, really enormous community of folks that are writing these recipes, these pieces of DSL out there to automate and install and configure things like Apache or IIS on Windows or what have you, right? And you can learn more about Chef at opscode.com. So what I'm going to do here is I'm showing how we've integrated DSC and Chef to enhance Windows as a DevOps platform. And again, you've kind of seen this before with how the demo has gone previously. We're going to install IIS. using this thing that we've written called DSC configuration script. And it invokes, as you see, a Windows feature resource to install IIS, just like it was bare PowerShell code before, right? And then what I'm also going to do is I'm going to write out just a default index page, right? Using, again, you can see a file resource in the DSC syntax, but what I'm doing in this case is I'm connecting sort of native Chef code here, which is the cookbook file resource that's built into Chef, and driving the DSC configuration script resource with stuff, right? So that kind of shows you how you can bridge the gap between Chef and DSC. So in order to run this demo, what I need to do is, I have a node registered in my Chef server. And what I need to do is to add those recipes that I've written to what we call the run list of the system. And the run list of a system is just an ordered list of things to execute, right? So you see I already have, this is how I actually personally set up my Windows systems right now if I need to do some testing, right? I have a couple of base things that I already add to those systems, right? I have some development tools. I have the DSC beta code on there. And what I'm going to do is I'm going to add those 2 recipes to my run list. I'm going to just drag this over to the run list. Oop, I need to make sure it goes down here. And drag the demo site here. Oop, let's go below there. And if I save this node, now what I need to do is to actually go on the system, and I need to run the Chef client to apply that configuration to the system, just as these folks ran the DSC configuration script on the system to make it go for their use case, right? So if I run Chef client, which is our agent, it's going to start up the Chef client, which is basically going to contact the ops code, the Chef server, and start downloading the configuration, the cookbooks that contain these recipes, and then it's going to basically start running through, and again, it's also idempotent, right? So it's only going to change the things that need to be changed on the system. It's going to go through and find out that IIS is not actually installed, so it's going to go through and try and install IIS, and then it's going to try and write out that default web page, right? So you can see all the things that I do to make the system, those are already applied, and the only thing that hasn't been done, of course, here is to install IIS. So that's going to take a little while.
Now, in this demo, you've logged in and you're doing it interactively, but in a production environment, this would happen automatically. Yes?
That's right. A typical way you would run the Chef client is as a Windows service, right? Or you would trigger it as part of some kind of DevOps process, right? So you talk about these 10 deploys a day. Somebody makes a change to a configuration. You're probably going to go through and, out of some continuous deployment pipeline, like with a Jenkins or a Hudson or whatever it is, right? You're going to go and trigger Chef to run and apply that configuration, those changes, right? So as you can see, it's running the LCM and going and what we call converging the node to apply that configuration and install IIS.
And of course, one of the big benefits would be if you had a configuration where you say you had maybe Windows backends and Linux front ends. You'd have one common tool to manage all of them.
That's absolutely right. The syntax, the Chef code syntax, is already familiar to a lot of people that are managing Linux and Unix systems. So to have this kind of extension, this thing built in, right? You may have Linux admins, or maybe they have to manage a certain set of Windows servers, or not totally, up on PowerShell, whatever. This gives them a really super easy bridge to be able to just go ahead and do that, right? They already know a little bit of Chef. This gives them just enough to manage the Windows servers, and then it's kind of a road for them to drive to get more adoption of the Microsoft tools, right? As they get more familiarity with managing the Windows platform. So I guess I had some kind of error here, but basically what would happen is then IIS would be installed, and then if I loaded the web page, then you would see the regular demo site.
Awesome.
Great.
Thank you very much.
Okay.
Thanks, Jillian.
Yeah, thanks very much.
All right. Is that the one?
Yeah, let's stay there for just a sec. So as Jeffrey's pointed out, this whole notion of this local configuration management that we're shipping in all the versions of Windows on the right-hand side enables people like OpsCode, Chef, and others to start taking real advantage of it and trying to build a community around it. Now, the question then becomes, okay, what are they building on top of? And the answer is that they're utilizing DSC providers. And how do you build a DSC provider? The answer is PowerShell. We've already got a bunch of PowerShell commandlets, some almost 3,000 as we move forward across Windows Server. And so we're going to leverage that capability. Not only do we leverage that capability, that itself leverages the whole SIM or standard-based element capability Jeffrey mentioned earlier. Anybody that implements the SIM standard in our way, they get commandlets for free, which we did with storage and so forth. And so now we can begin to try to write providers over those. So if I get a chance here, what I think I'll do is take a few more moments maybe and actually start to show you one of the providers we wrote.
Yeah.
So let's
In
see.
particular, we have this phrase up there. I realized I didn't explain it. We said that these providers implement monotonic code. This is Bruce's, Bruce Payette. Guy's a rock star. He's really into the details language. So monotonic, what do you mean? He says, it's relentless. It just keeps going. You just run it and it just keeps going, and you're just going to do whatever it takes to get from wherever I am to wherever I need to be. Looks at where I am, figures out where I need to be, and determines how to get from here to there. So if I do some things, but then a reboot's required, I'll do a reboot. When it comes back up, it figures out where it is, figures out where it needs to be, keeps on going. Another reboot's required, it'll reboot, and then keep going. Okay, so it doesn't always start from the beginning. It always figures out where it is, figures out where it needs to be, and then gets there.
So here's what we got. If you take a look at it, a desired state configuration provider implements 3 PowerShell functions. They implement a get. We haven't shown that much, but essentially a get says I can go to whatever system it is and get the current configuration, which is really useful if you want to figure out what went wrong, right? It could be useful over time as you try to say, hey, I got a node right there that's right. I want to get its configuration, mess with it, replicate it, etc., right? So get becomes both a useful debugging tool, a useful creation tool. And it gets not only the resource you specified, but other ones that are available in a read-only manner. I'll show you that a little bit. At least I'll show you what the code looks like. And then the second thing is you implement this test. We've talked a lot about the test, and the test is vital because that's what we use to check whether or not we need to call the set. You got to get the test right. That's actually the important part of the model. And the second one is a set. That's the make it so. And that's where we actually make it so. Now, how do we tie these together? Well, if you just take a look at the test, we have this parameter block, right? This is basic PowerShell code. We have a while, stop, and we have this parameter code, and look at that, right? Is it present? What's the name? What's the physical path? Well, if you go back...
Yeah, show them IntelliSense. You never showed them IntelliSense.
I'm going to let you do
what
that.
The heck?
I don't know. You're going to... Would you like to show them IntelliSense? You can show them. As soon as I finish this, you show them IntelliSense. Is that good?
Okay. Yeah.
All right, I'm good.
Is it going to work?
I don't know. That's why you're doing it. Probably. But if you take a look at the, where was I? You just totally distracted me. All right, so here we are on this website, bakery website. You have these properties, right? Ensure, name, state, physical path. Requires is supplied by the system. And over here, what do we have? We have ensure, name, physical path, and state. You see the match? Right? That's exactly how you say, here's what I want to enable someone to specify for me. I want to enable them to specify the physical path and the state and the name, and that's it. And ensure should only do present or absent, so you could remove it and so forth. And it's the same exact set of parameters as one might expect with the set. Right? It goes back to the same exact thing. Then on the test side, of course, you want to make sure that if it equals present, that you're actually checking to make sure, okay, if it's already there, is it not? It gets the website. It does some other checks to make sure that, in fact, it's going to exist. And that's the set. What I wanted was the test. Very, very much. There you are. Right? It goes as in check if it's present, the website's null, ensures absent. So it does a fair bit of complex logic. This is the number one stuff, okay? But the good news is that underneath this all, it just calls the PowerShell commandlets. It just checks to say, hey, what do I actually want to actually have happen? It does the get website. It writes it out. In the set, I can show you the PowerShell commandlets, flipping through the code somewhat. There you are, right? It just calls another website. Off we go. No big deal. Now, what's also kind of nice about this, just checking the time to see if we're going to have time for your, very cool demo. Is when you actually get a chance, you can actually go to one of these other systems. Let's see if I can do this one here. TSN Web Server 1, right? All right, nothing there, that's fine. And we can actually do an import module of that module. Did I type that wrong?
Dash name.
Import module dash name?
I think so. Just get rid of dash. Yeah, just bonk. Do that dash verbose so people see what happens.
There you are.
See, so each one of the nouns has the same signatures. Has get target resource, test target resource, set target resource. And then it has some other stuff. But they all have the same.
All right, and so you got your get, your test, and your set. So as we started to debug this, occasionally what we'd find is, okay, where was it really at? And we'd actually go to the target node system and run the test exactly with the same set of parameters that we then pass because it's just a function. So that's the kind of thing you can start doing once you start leveraging the PowerShell syntax and commandlets. I'm getting out of here.
Okay. Now, here's the interesting thing. This one is for the PowerShell Uber geeks in the crowd. If you're not an Uber geek, this is going to go right over your head, so don't worry about it. It's just so cool. So for you geeks, take a look here, right? Think about this. This is a PS1 file, right? And so these things are effectively building hash tables, right? And remember that all the resources have the same signatures, which are for get, set, and test. So effectively what we're doing is we're taking this hash table and we're using splatting against each one of those commandlets. I see you figured it out. Boom.
That's right.
So this is like crazy inner baseball, but if you're into inner baseball, it's really cool. Now the point of this is how we're able to do things like, let's see, where am I? Bonk.
Intelligence running, it's on the bottom.
Where's that? Okay. Did I mess that up?
I don't think so, dude. There it is. Oh, there we go.
Okay, sorry.
It's taking a while to load all the modules.
Okay, oh, right, loading all the modules. So here it's showing me that I got a key value pair. What am I doing? Website. Name. Okay, I don't want name. I want... I'm screwing this up. Website.
There you are. That's what you want.
New name. What things can I put in there? There. It shows me all the things that I can put in there. Okay? And how does it do that? Well, because we understand the module, we're able to look at the signatures, we're able to find the parameters, and we use those parameters to then feed the IntelliSense. That's why it took a while. We had to go import all that stuff. So, and again, if I go and I do something, which one are we on? Website 2? Let's do this one. If I do foo equals bar, notice the squiggle brackets. It knows that that's unacceptable because it doesn't match the schema. And if I went to try and run it, let's try and run it. Can we run this? Where are we? Am I in the right place?
You're going to want to go to, I think, 2, right?
Yeah.
Assert, I'm going to let you assert website 2, right?
It was website 2, yeah. Oops, sorry.
I just screwed up. This is why we have tab completion.
2. By the way, here's a trick. It's called clear screen. Clears the screen. Okay? And so here, if you get the schema wrong, right? So here's the thing. If you're going to change a system, you either want to not change it or change it and be successful. Okay. Half changes are not good. So any kind of schema validation that you can do, we do the schema validation before you start messing with the systems to ensure that it's going to work. So there's a bunch of stuff there. Now I do want to highlight that this is, version 1 of this feature. So the set of things you can configure are really quite limited. However, we have one, which is our get out of jail free card, which is basically a script. And do we have a demo of that, or just tell you about it? We can show it. But basically, it allows you to embed the scripts itself, and you provide the get, test, and set signatures yourself, or you get it from the community. Now, the whole point I was trying to make here is these configuration management tools. There's a bunch of configuration management tools for other environments. But with Windows, it's been difficult. And the reason why it's been difficult is because of the API-oriented nature of Windows, which is really quite an advantage, except for things like configuration management. And so what we're doing is we are transforming that. We are using DSC. We will go out to the industry. We will get everybody to write DSC providers. And in doing so, in an open way, then it enables a wide range of tools. System Center tools, inbox tools, System Center tools, ops code tools, anybody's tools that will be able to manage us, all using the same providers. Today, these guys are all each going out to the individual vendor and saying, hey, write a provider for me. And they'll say yes, or they'll say, no, I've decided to line up with somebody else. And that world just doesn't make any sense. So we've taken a platform approach to trying to solve that.
I'm so glad you did the ISC demo, actually. And he makes a good point about the configuration. What we don't do is we don't try to do real runtime conflict analysis or something like that. We own that machine. That MOF thinks it owns the machine. It goes forward. What we do, because we have a single MOF per target node, we make sure that it is possible to execute. That is to say that any resource conflicts occur before you generate the MOF. In fact, we didn't highlight it, but one thing you actually saw us do when we added a VM automatically is we actually had a configuration calling another configuration. Mm-hmm. And as soon as you get into that world, he's doing a configuration, he's doing a configuration, she's doing a different one, and maybe you're getting someone from third party. That idea of the conflict resolution before you get to the MOF is really important. So let's see, I think we got maybe one more demo we got time for. Well, let's flip back here first.
Yeah.
Now, watch carefully.
Big change. Did you see
There
it?
you are. Did you see that? Should we do it one more time?
Do it again.
There you are. So far we've been talking about a push model, right? You write your configuration, you send it, you push it out.
If you didn't see it, what changed was we changed the middle words from being push server to pull server, and we now have these two arrows. Okay? So the first example was a push, where I'm here and I push the configuration to that machine. Now we're going to talk about pull.
And so here in this case, on a pull server, what's going to happen, right? It turns out all you have to do is create a VM that has a URI to the pull server and a unique identifier. The VM goes to that pull server and says, this is who I am. And the pull server looks aside in its store of configuration and says, oh, this is yours, and gives it to it. And the VM brings it back to this local configuration manager and says, all right, what do I do with this? It analyzes all the resources. When it does the analysis of the resource, it asks itself, do I have a provider for that resource? If it doesn't, guess what it does? It goes back to the pull server and says, hey, I need a resource. Here's its name. The pull server brings it down that module, because it's just a PowerShell module, which is essentially a zip file with anything you want in it, brings it down, unpacks it, and starts to try to make it so. So in the time remaining, we'll at least kick it off. It takes a little while because I'm creating VMs.
Yeah,
you
no,
should
he
be able to get
does
the
that.
notion
I
about
got to
this.
tell you, I've got a live interview in 5 minutes, so I'm going to let Kenneth finish this talk after I make 2 points.
Please.
First is, this is super cool stuff. So this notion is, I mean, think about how virtual memory works. Virtual memory says, I'm going to lie to you. I'm going to tell you this got much memory. And until you use it, that's fine. And when you do use it, I detect it, and then I go get you that memory. Well, this is exactly the same thing. I'm lying to you. I'm telling you got all these providers. Trust me, it's fine. And when you use it, then I go and I say, okay, great, now I'll go get that provider for you. And we get it from the remote machine and we bring it. And if you don't use that provider, we don't bring it. Because you know what? There might be a ton of providers. We only want to bring down the ones that you use. So effectively, we're applying virtual memory techniques to management. So that's very cool. And net is this desired state configuration is kind of like finishing the cycle we started 12 plus years ago. But that does not at all mean that we're at the end of PowerShell. If you take a look at each one of our missions, you know that we have plenty of room to grow and plenty of room to do things. So this in no way ends things. I'd say that this is not the end. I'd say it is the
Beginning number 2.
The end of the beginning.
Yeah.
And now we're on to the next phase. Having flushed things, filled out the basic structure, now we'll fill it out with more things. So with that, I'll leave you to Kenneth to finish up.
All right, finish up mode. So what we've done is I've actually paused it just a little bit because I wanted to show you what's going to occur on the poll server. So I ran the assert after doing a clear screen almost. Or I should have done a clear screen. Anyway, I ran the assert, and it's gone ahead and generated all the MOFs, and it's created, indeed, 2 new VMs, Web Server 1, Web Server 2. I cleared them out before. We didn't show you that part. We just cleared them out before and started again. Now, those things are kind of paused. And so what I'm going to do is we're going to try to go ahead and log in to Web Server 1 because I want to show you that part about the modules. There it is. See, where am I at? It's CD, C, program files, star, PowerShell, modules. I do love tab completion. All right. And the key thing is there's nothing there. Here, just to make sure that everybody feels good about that, I will clear the screen. I'll do a dir again, and there's still nothing there, okay? Nothing there. And what does that mean? What that means is the module on Web Server 1 is not yet downloaded, right? So it doesn't have it there. And so I'm going to come back here to the host server, and I'm going to invoke poll mode. This is just a way to sort of ping it and say, okay, continue on. It's kind of for my demo. It tells it to keep going. And I'm going to have to say web. I do like prompting when I forget. Server 1, server 2. I think that's all I have. There you are. It'll get going. And then we'll come back here because, again, what it's doing is it's now going to actually say, download that MOF. It's already created the VM. Now it's going to download the MOF. It's going to start to analyze it. It's going to recognize that it needs a module here. It needs a resource. And in theory, there it is. Right? Now, ain't that sweet? Now, here's what's kind of cool about that, I got to tell you, is if you go inside demo website, notice what else we have. Certainly, we have the module here, and this is the MOF schema that tells you what we can do, but you even have the content for the bakery site that's been downloaded with the module. It's all come together as a package. And if you come up here, where am I? Yes, I'm actually on the poll server. And if you go through, you'll actually see these are the MOFs. This is the one we downloaded to check. We use GUIDs as unique identifiers, right? And the module content is all here. And this is just the demo IS website zipped up. It just took that thing, said, yea, verily, I need it, downloads it, and shoves it on the box. Now, in theory, it's true. All right, we got rid of our third one. I don't know where these are at anymore, I confess, because what's cool about the pull model is they do sort of happen on the fly behind the scenes as you go forward. And we have IIS, and I've done something to Web Server 1. It appears that I have. It's still working away. And I'll get out of this thing. In case I fat finger it, you never know. There you are. And it'll just keep running for forever. So this is going to take a little while because you have to install the IIS and everybody else and move forward. You'll get exactly the same sort of fourth copy that you got before. Oh, he wants me to refresh. There we are. It's all working before. Anyway, I'm going to hit. There you are. Okay. Thank you. We believe you. Thank you very much. All right. So that's a pull model. Module download, automatically instantiate. Magic sort of happens, but you can keep track of it. And now for the couple of final slides, we close this down. People frequently ask, how does this relate to Systems Center Virtual Machine Manager? We just showed you. We showed you all this stuff. This is for your reference later. Related sessions at TechEd. You get that one, but we got like 30 seconds to close out, so I'll be happy to show it to you after. It'll be in the deck that comes out. We have other related sessions. There's instructor-led labs. It's probably worth trying to go through and do it again. And let me just close out with a quick statement about what we've done with desired state configuration, the intent, if I could. First, we have really simplified configuration. If you take a look at anything like a script to do what we have done today and compare that with when we said ensure IIS present, they're just not in the same universe. We've already separated structural configuration, configuration itself, from idempotent automation. And again, we've separated structural from environmental configuration. So you only have to change what you need to change. We've shown again and again that when the systems do get screwed up, you just rerun things. Just run it again and again, and life will be good. We're going to rerun the poll again just for fun, right? And so here we go. Things just begin to work themselves out of the system. And we're beginning to create an ecosystem. And this is really vital for us because in the end, the system is only as good as the things you can manage. We're layering that ecosystem over PowerShell. We're going to start empowering people like Chef and others to actually come and build systems on top of it. Thank you very much. We hope you guys have a wonderful day.